Okay, let's talk about inductive reasoning. So, inductive reasoning is the process of reasoning to a general conclusion through observation of specific photons. So we look at the photons given this sequence. Okay, I have 4 sequence, so there is some missing number we're going to find. If we can actually find more than one, any missing number is requested, we can find by using the inductive reasoning. Okay, so we will look into their photons, we make a valid argument. Okay, we look into their characteristic, so we make valid argument, then we come up with a conclusion. Actually, what is the number could have been. Okay, so let's jump into this number. Okay, let's jump into this number and let's see we can actually deal with it. If you know how to do it, right, you can do it and check the answer. You pause it and check the answer later with me. Okay, so between 2 and 6, what is going on? What is the relationship between 2 and 6, and what is the relationship between next two numbers and so on, right? Is there any common number you're coming up? So this is what we have to look into. This is called phaton. Okay, or it doesn't have to be one after another, it can be some gaps also. Okay, like I want to mention here, if you see every time 1 1 1 is the gap, that means that's a phaton. If you see every time 2, like 2 4 6, yes, that's a phaton. If you see 4 8 16, that's a phaton. If you see 2 4 8 16 32, that's a phaton. So many photons. Or you can divide, you see some phaton, or you can try to add two number previously, that would give you another phaton. Or sometimes you won't have a phaton first time, it's going to give you something, you come up with that. I want to reiterate this here. So maybe it's going to be 1, then it's going to be 2, and it's going to be 3, then you come up with a phaton. So sometimes phaton is not there. Actually, you have to use the critical thinking also for this case. Okay, so I'm looking to this one here. I clearly see the difference is 4. Also, I clearly see the difference is 4. Also, I clearly see the difference is 4. So every time I try to subtract second number from the first number, it gives me 4. So therefore, our difference is 4, which tells us that this is going to be an arithmetic sequence. Okay, so in arithmetic sequence, we just add the difference with the last number will give us the answer. So 14 plus 4 is going to be 18. That is the missing number. Okay, that is how we use inductive reasoning to find the missing number. Let's take a look on the next number here, next one here. Okay, so next one in this case is given as a 4, negative 20, 100, 500. Look, if I try to subtract, it's going to give you negative, well, it's going to give me negative 20 minus 4, which is negative 24. Is that negative 24 next one? Let's check it out. 100 minus negative 20, which is 120. No, we cannot think about subtraction or addition in this case, right? So it doesn't work. You clearly see that doesn't work. Okay, so what we have to come up with? We have to come up with some other way. How about division? So if I try to divide, let's see if it works. Negative 20 over 4, you got negative 5. Let's take a look a little more. 100 over negative 20. Seems like we are getting negative 5. We have to inspect all of them actually. Okay, let's do the next one. 500, sorry about that, 500 divided by, which is negative 500 divided by 100. That would give you also negative 5. So look, every time you clearly see there is a outcome. There is an outcome which is the same outcome clearly, right? So therefore, since we divide, now we're going to do the opposite. So we're going to multiply. Multiply by what? We're going to multiply by negative 5 times 500. And that would give us 2500. So that is the missing number in this problem. Okay, that is the missing number is going to come here. Very nice, right? Okay, so you know that inductive reasoning we are using. Okay, so look, if I look into C, right, look, you try to subtract 4 minus 3, which is 1, 7 minus 4, which is 3. No, it doesn't work. You want to try 11 minus 7. It doesn't really give you same, or there's no other phaton you can come up with that. Okay, then what? We're going to divide. So if you divide, actually it's not going to give you anything on that also, because if you divide, you're not going to get same number. 4 over 3 is going to give you some decimal number, and next one is going to give you decimal, but they are not same, therefore we are not going to look into the arithmetic. How about, oh yeah, arithmetic and geometric. How about if we look into C, if we add previous two, for example, this is every sequence, that is your S1, this is your S2, S3 by definition must be addition or sum of previous two, so it has to be S1 plus S2. That is the definition of a Fibonacci sequence. So clearly seems like it works in this case. Look, S1 is 3 plus S4 is 4, so 4 plus 3 is 7, and actually we are getting this 7 here, as you see. And if you add these 2, it gives you 11. If you add 7 plus 11, it gives you 18. So every time you adding previous 2, adding previous 2, adding previous 2, previous 2 gives you the next one. Next number. Okay, so if something like that, right, is basically a Fibonacci. Okay, so we're going to do 18 plus 11, that would be 29. Okay, so that's how we find this one. Let's take a look onto the next number here. Okay, so this one is 1. Clearly I see next all of them, rest of them is basically your fraction. Well, no problem, we can actually divide this one by 1, so we have a fraction on this one. Now question is, on the top is all of them 1, what is on the bottom? It's not same. Is there any specific pattern we can find? Is there any value argument we can do here, right? I clearly see there is a increasing by 3 times. As you see, first one is 1, you multiply by 3, multiply again 9, and then so on and so on. Now if you divide 1/3 by 1, what you get, you're going to get the same thing as a 1/9 divided by 1/3. So obviously I'm going to multiply by 3 on the last one, so my answer would be 1 over 81. Yeah, 1 over 81. And of course this is geometric, we can say this is ratio clearly. Okay, so this is a ratio clearly, so you can check this out. Okay, you can check this out, and you can come up with more example. Okay, if you have any question, you have any new example, you can put in a comment box. I'll try to make another video out of it. Okay, thank you very much. I hope you understand.